Imagine waking up one morning and noticing a small crack above your living room window. First, you ignore it. A few months later, the crack has grown. Your doors no longer close properly. The floor feels slightly uneven. Is your house falling apart? Or is something much bigger happening beneath your feet? The truth is that most serious building problems don't start in the walls. They start underground, where you can't see them. Today, we're uncovering the hidden science behind why houses crack, why some buildings remain perfectly stable for decades while others begin to sink, and what engineers do to prevent these problems before construction even begins. Let's dig beneath the surface. 1. The real job of a foundation. Your house is only as strong as the ground beneath it. Many people think a foundation simply holds up a building, but that's only half the story. A foundation's real purpose is to spread the weight of a building safely into the ground below. Think of wearing high heels on soft sand. Because all your weight is concentrated on a tiny area, you sink. Now imagine wearing snowshoes. The same body weight is spread over a much larger area, so you stay on the surface. Foundations work exactly the same way. They spread the enormous weight of a house over enough ground so the soil can safely support it without excessive movement. If the soil is strong enough, the building stays stable. If it isn't, problems begin. 2. Why buildings sink. Did you know that buildings are actually expected to settle? That sounds alarming, but it's completely normal. When a new building is constructed, the soil beneath it compresses slightly under its weight. Engineers call this settlement. A small amount of uniform settlement is expected and usually causes no damage. The real danger occurs when one part of the building settles more than another. This is called differential settlement, and it's one of the leading causes of structural cracking. Instead of the whole house moving evenly, one corner may sink while another stays put. That uneven movement twists the structure, causing cracks in walls, uneven floors, and doors or windows that suddenly refuse to close properly. 3. The hidden role of soil. Not all ground is created equal. Two neighboring houses can experience completely different foundation performance simply because they're built on different soils. Some soils, such as dense gravel or rock, can safely support heavy buildings. Others, including soft clay, loose sand, peat, or poorly compacted fill, may compress much more under the same load. That's why engineers never guess what's underground. Before construction begins, they investigate the site using methods such as desk studies, trial pits, boreholes, and soil sampling. These investigations reveal important information like how much weight the soil can support, groundwater conditions, soil type, and hidden obstructions beneath the surface. This information allows engineers to choose the right foundation before the first brick is ever laid. 4. The tree that can damage your house. Can a tree really crack your house? Surprisingly, yes, but not because the roots are smashing through the foundations. In many cases, the real problem is water. On shrinkable clay soils, large trees remove significant amounts of moisture from the ground. As the soil dries, it shrinks. If this shrinkage happens beneath one part of a building more than another, uneven settlement or subsidence can occur, leading to cracks. Now here's the twist. If that same mature tree is removed, the clay can absorb moisture again, expand, and push the foundations upward. This upward movement is known as ground heave. In other words, both growing a tree and removing one can affect buildings under the right soil conditions. 5. Water, the invisible enemy. One invisible change underground can move an entire building. Groundwater plays a huge role in foundation performance. If the soil becomes saturated, it may soften and lose some of its strength. If it dries out excessively, particularly in clay-rich soils, it may shrink. Leaking drains, prolonged droughts, poor site drainage, or changing water tables can all influence how the ground behaves. That's why engineers don't only design foundations. They also consider drainage systems, groundwater conditions, and long-term moisture changes to keep the soil as stable as possible. 6. How engineers prevent houses from cracking. The best way to fix foundation problems is to stop them happening in the first place. Good engineering starts long before construction begins. Engineers carefully calculate the building's weight and compare it with the soil's bearing capacity. If the ground is weak, they may choose a different type of foundation, such as a raft foundation or deep piles, to spread or transfer the load more effectively. They also ensure fill materials are properly compacted, foundations are built to suitable depths, and structural loads are evenly distributed across the building. On some projects, engineers even monitor buildings after construction using settlement markers or sensors to detect movement long before serious damage develops. The goal isn't simply to build a house. It's to build one that remains safe and stable for generations. 7. Not every crack means disaster. Here's something that surprises many homeowners. Not every crack is a sign that your house is sinking. New homes often develop tiny cracks as they settle under their own weight. Plaster can also crack as it dries, and buildings naturally expand and contract with changes in temperature and humidity. However, wider cracks, especially diagonal ones around doors and windows, cracks that continue growing, or cracks accompanied by sticking doors and sloping floors, may indicate ground movement and should be professionally assessed. Conclusion: the next time you notice a crack in a wall, remember this: the wall may simply be revealing a story that began deep underground. The stability of every building depends on a delicate balance between the weight of the structure and the strength of the soil beneath it. When engineers understand the ground, choose the right foundation, manage groundwater, and design for changing soil conditions, buildings can stand safely for decades, even centuries. But when that balance is lost, the first warning sign is often a crack that seems harmless, until it isn't. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications for more fascinating explanations about how buildings and the world around us really work. And here's a question for you. Have you ever noticed cracks in your home and wondered what caused them? Share your experience in the comments below. We'd love to hear your story.